Hey chat, what's up? So I figured we would, continue the game detective thing today because I've been given like a possible hint-ish thing.
You're not gonna get it.
Maybe. just maybe. So I kind of want to crack it now. So as you heard, we have a guest today. Say hi to Bram.
It's me. Hi.
Yeah, we'll probably be like either playing another one of these code things later, or maybe some keep talking nobody explodes. We'll see. We'll figure it out. It's probably not gonna be a very long stream, but yeah, we'll see.
We'll see.
We'll see. So let's switch over to the game detective. We do not want to capture similar windows, that's correct. There we go. Yeah, so we were at the D&D sheet. And apparently, or like, Bram believes that the answer is one of the very first things I said. I don't remember what I said, so that's kind of problematic. But it was one of the first things I noticed. So I figured let's just try that again. Or something like that. I don't think I remember the first thing I noticed. I noticed the name. But we already tried that.
Yes, you already tried it. With the muffin. That's one of the first things you noticed. It's correct. And I think it was even the first thing you noticed on the whole sheet.
I don't remember the first thing I noticed on the whole
That's
sheet.
why I said you're not gonna get it.
He's teasing. I don't like it. Okay. First thing I did was read the text. So let's just try to replicate the situation as much as we can. All right. The last puzzle in this course is this character sheet for Dungeons and Dragons. No knowledge of the game is required to solve the puzzle, although it may help. There is a lot of information here, and only a fraction of it is relevant to the hidden message. Discerning what's important from what's not is a crucial skill in I can't read. Puzzle solving. Pieces of information that are not relevant to the puzzle itself are often referred to as red herrings. This puzzle has quite a few red herrings. Good luck. I remember I checked capital letters. Because I think I saw somewhere where I thought it said pass, but that was it. I can't remember where it said that. Oh, no, it doesn't. Let's just spell out pass, though. I thought it was like the capital letter spelling out pass.
No, I think you said pause here and you are searching for a word. If I heard it correctly, because I wasn't.
I was looking for word, yeah. Oh, yeah, I was. But there was no word on the sheet, was there?
Correctly. Correct.
Was that it?
No.
What else did I check? I checked. I don't know. But you say it's not D&D related, right? It's not D&D specific.
It would have helped if I came to the conclusion directly because I know it's not possible in D&D. Not in the beginning.
But he's level 8. It's not quite the
Yes.
beginning.
Okay, but it's very, very, very unlikely. Even at level 8.
I remember talking about like these points.
Yes. What did you say?
You have the way this works is that you have a certain number of. Are you kidding me?
2 isn't.
Are you kidding me?
It's the first thing you said. Even if you roll, it's 3d6. So the minimum would be 3.
Fine. I hate it. I hate it here. I hate it so much. Because we start when we play that one session of D&D, we started with like a certain number of points we
Yes.
already could assign, right?
That you have a base, I think it's 12, and you add up 1 with 3, 1 with 2, 1 with 1, and back. I think so.
Oh.
You have a base, and then you divide points.
I see. Well, then 2 is extremely low.
Extremely low. It's possible, but you have the intelligence of a plant. So when you said 2 is a possible number, I laughed. Because it wasn't.
Fine. Fine. Well done. In this course, you solved a few types of puzzles and learned some methods of I still don't like that word. Steganography in the process. Just to recap, steganography is a way of hiding information such that the presence of the hidden information is not apparent, and a red herring is a piece of information that is irrelevant to revealing a hidden message. Congratulations. Hopefully, you feel more equipped for puzzles you encounter in the wild. You've also earned a badge. Badge! I still wonder whether this is actually a code, though. Because they make it seem like it is. But I don't know.
I thought the first letter of each word, but that's not gonna go to something.
Nope. Last letter isn't either. But it's like these words don't even make sense together.
In contrast, the text looks more innocuous, but contains a hidden message. So there is a hidden message in that.
You would say so. But you can't check anywhere what it will be. Because maybe we should check this. Because if that is not a hidden message, then again, will we be able to tell that for sure? Let's try. No, let's not do it like that. Wait, is that... That could be hexadecimal already, right? Doesn't seem very likely because we have...
Yeah,
These are very far apart.
it doesn't seem likely. And 1E is... I think over 20, but I don't know for sure. No. Yes.
We can try. Hexadecimal to ASCII decoder? But it's not necessarily to ASCII, is it? Just hexadecimal decoder. Abe! Hey, Tay! What's up? How are you today? Let's try to decode this. That's not a hidden code. Not that's well. It's not hex as a hidden code.
I wouldn't think they would already copy paste hex in that stage. Maybe. Right?
Why not?
They are beginning. We're beginning to go, right? So
Okay, fine. There was also this cipher analyzer, yes. I think it's this one. Analyze text. Let's see what this one thinks. It does say hexadecimal.
It's not though.
This is not very useful. Also, Tay says hi.
Hi.
He also gave you a wave. Just, you know, FYI. I don't know. Oh, wait, we need that one. Because if it's not hexadecimal, what would it be, right? There's also nothing odd in the words. I was looking at like double letters or something like that. So it's not like middle letters because a lot of the words are even in amount of letters.
I'm gonna try something.
What are you gonna try?
The number of the letters.
Doubt it.
I doubt it too, but
Because that's D, B, D. And unless we're gonna go by Dead by Daylight stuff, doubt it.
and then I thought words, how many words, but then you get 4,
4, 5, 6, 7, 2, 3, 4, 5, 2, 3, 4, 5, 6, 6.
7, 5, 6. That doesn't look good.
Well, that could be Jeff.
Okay, could be. Don't think it is, but it could be.
And I doubt it's gonna be something as random as in, take the next to last letter or something, right? Would not make sense. Well, it could, but it'll be extremely random. How much time do we want to spend on something that may not have a solution?
But it says that it contains a hidden message.
They could be trolling.
Could be. I let it up to you. I leave it up to you.
Let's do something else then. So, is there one that you would really want to do? All of them sound like a lot of fun. I think this one's gonna be difficult.
That's gonna be difficult. I thought image steganography. I do think that's a fun one. That one just getting off basic steganography. So do you want to go?
Let's do it. Yeah, let's do that. Let's finish it. Welcome to image steganography tutorial. I don't like that you're making me say the word more often though.
Yes.
In this tutorial, we're going to learn a few common methods to discover messages hidden in images. Before you begin, it's strongly recommended that you first complete basic ciphers. We haven't done that one.
Maybe we do that first then.
Okay. Welcome again. In the basic computing tutorial, we'll be learning a bit about the inner workings of your computer. Oh gosh.
Yes!
Specifically, we'll be looking at how a computer interprets text and how we can use that knowledge to solve some new ciphers. If you haven't already completed the basic ciphers tutorial, we suggest that you look at it before continuing with this one. Otherwise, let's get started. If we're gonna look at how a computer interprets text, it's gonna be binary, isn't it?
Binary, ASCII, maybe hex.
At a fundamental level, maybe.
It's binary.
Hey Raph, what's up? We are going through some of the basic codes and ciphers and stuff. So this is about the most basic ciphers that you'll see in not necessarily escape rooms, although that's possible too, but your brain hurts already. We haven't even started yet. Things like ARGs, for example. So at a fundamental level, digital computers store information and perform operations by using a series of zeros and ones, binary. Here's an example of what binary looks like. You wanna decode it?
Buy a decoder.
Good. Because I really don't want to count. Not waiting for that. Do we have one here?
Yes, I think.
I figured I'd take the lazy route. Binary decoder.
Yes.
I didn't see it in the list.
Yes, but you needed to go.
Binary Easter egg. Oh, funny. 1 + 1 is 2. That's almost binary. Good job, Raph. My head hurts too, but not because of this. Sorry, Tay. But what is binary? Well, it's a system of counting that is different from our normal ways of counting. We typically count upwards using 10 digits. I'm not going to read them out. Because there are 10 digits in our system of counting. We call it base 10 or decimal. By contrast, binary only uses 2 digits, 0 and 1. For this reason, binary can also go by the name base 2. Giga brain. Yup. You're already skipping steps.
They don't know how.
I really love the joke. There are like 10 types of people in this world. Those who understand binary and those who don't.
Yes.
Let's look at an example. Here's how the number 109 is represented in base 10. It's 100.
And 9.
0 tens. And 9. How do you call these in English, by the way? They're not digits, right? I want to keep calling them singulars or something like that, but I don't think that's the word.
Exponents? No, that's not what you're...
That's not what I'm referring to, no. No, it's this line. Like you've got your thousands, your hundreds, your tens, and your... Google. So you've got your thousands, your hundreds, you've got your tens, and you've got your... Google.
Google is one with zeros.
Do we just call it ones? Units. I had kinda hoped that would like... Units is an interesting term for that, I think. Wait, what is that? Sweaty. Note that the place value of each digit starting from the right side and moving left is 10 times the value of the previous digits. Yeah, that's kind of what this does. But sure. That's because we're using base 10. Now let's look at the same number in binary. Which means you get a whole lot more digits. So 109 is 1 times 64 plus 1 times 32. etc. etc. Let's not do the whole thing. Now, because we are in base 2, the value for each digit moving to the right, from the right to the left, is only 2 times the value of the previous digit. So the 109 in base 10 is equal to this.
0110101.
That in base 2. We opt to keep the leading 0 since binary normally is normally displayed in groups of 8 digits. Now let's try converting from binary to base 10. It's displayed in groups of 8 digits because 122, that's like... Well, that's not ASCII maximum, right?
No, it's most of the time they do 4, 8, 12 and 16 because it's really easy to get them to hexadecimals.
Hexadecimals. Gotcha. Now, let's try converting from binary to base 10. Keep in mind that the rightmost place value is worth 1, and each place value to the left is worth twice as much as the previous. Convert this number to base 10. Should we even ask chat? Do you think that would be very fruitful?
I think they need to try at least.
Well, chat, you hear it. Why don't you give it a try? I don't know how readable that is, actually. Seems better, right? Thanks for trying, though, Tay. So this one is 1. Watching on a small screen. Yeah, I figured. I feared. Maybe that works. No worries, stay. Gotcha. Let's make it a little bigger though. So we start at the end, so that is 1. Then the 2 is a 0, so we don't count the 2. The third one is 4, so that makes 5 in total. And then this one is 8, so that makes 13. Agreed?
Yes.
Agreed. Nice. You managed to work it out. Next stage should now be unlocked. Yup. Nicely done. Now we're going to apply this knowledge to learn a little bit more about computers. A single 0 or 1 is known as a bit, which is an abbreviation for binary digit. I didn't know that.
Me neither. Because these blocks of 8 bits are called bytes. This is...
You're skipping ahead again.
Yeah. That doesn't make sense for me. But I'm skipping ahead.
However, it is difficult to ascertain any meaning from the single ones and zeros. For this reason, computers are typically read in bits and in blocks of blocks of 8. These blocks of 8 are called bytes. Yeah, I don't know who came up with that.
Me neither.
Just to briefly test this concept, how many bytes are in the binary below? I don't want to. 3, 6, 1. 3, 6, 1.
Why not count with 4?
Because this is easier to keep track of. 3, 6. Help. Right here. That's 3. 3, 6. Fine. 4, 4. So that's... I lost track.
8.
That's not 8.
8 bytes.
I got stuck at like 6, I think.
Yes, and...
Fine.
Okay.
Now my track record. I had not gotten any of them incorrect yet.
You did.
Did I?
The D&D cheat.
I didn't get it incorrect. I hadn't tried yet.
But why were you stuck with 6 here?
I wasn't stuck with 6 there. I was like, I reached the end and I'm like, I think it's 6, but now I'm not sure anymore. So, 1, 2, 3.
Okay, it's 6.
4. Okay, it's 6. Alright, cool. Now here's the interesting part. Each individual letter you see on screen is produced by a byte of binary. Here's what this looks like for the first word of this paragraph. What the computer sees in binary and what you see as a letter.
This is ASCII already.
It is ASCII already. You're skipping ahead again.
No! I just saw its numbers and I know A in ASCII is that. Because it begins with a 0, 1, 0 and that's a capital.
You're going too fast. Binary can be used as a cipher because it's a method of concealing information. It's much harder to read binary than plain text. But what is the conversion process here? How do we get from a byte of binary code to a letter? The answer is ASCII, which is a standardized way of transforming numbers into letters. Let's take a closer look at the top row of the table above. We start with a byte encoded binary. That one. Turning this into a base 10, we get 65. What?
Why? Why are we decoding to a decimal?
Because ASCII code usually, if you want to do ASCII by hand, usually you have the in-between step of first coding to decimals and then checking out what the ASCII
Okay.
decimal is.
Yeah, at school I learned different and how it is set up. So
Wait,
in school you learn what the 3 beginning means and what the 5 at the end means. So the 3 is always and the last 4. So
that is so cool.
But I need my textbook at home to show you. But and that's why I didn't think why the.
But that makes so much sense, because this is 9, which is an int letter. Like,
Yeah, and the first 3 say that it's a capital or non-capital. That's why I said ASCII, because
and that's 12. I didn't know that.
And that's why I thought, why did you set it to decimals?
That is so awesome. No, I was taught to do it this way. To first go to decimals and then check the ASCII table, because there is no way that you're gonna. Okay, you might remember that 65 is capital A, but no. That is so cool. Cause then, this is, wait, yeah. So this means small letter, and then it's 1, 2, 4, 8, and then it's 8 is H, and oh my god, I love it. So great. Anyway, if you don't want to do it that way, not gonna lie, I have no idea what's going on. I'm fangirl over mathematics, I guess. That's what's going on.
Not over mathematics, but how they designed the code.
Can I introduce you to Tay? This is mathematics.
Okay, yeah, okay.
Sorry, Tay. Yes, exactly. So wait, why do we have it open so many times? Did I click it that often? No, I did. Please don't.
Why?
Please don't. So we were looking at, okay, so we had this binary code which you could convert to the number 65, and then we went to this table. Fine, whatever. And if you then check out 65, you're right here, and it.
Okay. Why?
Let's find a better one. We're just gonna find a better one. Wait, I don't want a table. I want that one. I'm too late. Touch. No wonder none of this makes sense to me. Whoops. Wait, what is that? What is that emote? Because I don't know that emote. Is that a new one? I thought it, like, at first I thought it was a smiling ghost or something. But it's not. It's a very sad leafling. New 5 happy mode. Oh, cool. Well, it's sad, but never mind. Anyway, so 65 becomes an A. What's this one now again? Oh, that's hexadecimal. Gotcha. He added it yesterday. I still have to check the VOD of yesterday, but it's 18 hours long.
It's not.
It's not gonna happen. I'm not gonna see the whole thing.
Then you really.
Well, I've already been told I can skip the Twitch Rivals part because that was terrible.
Oh, but I don't watch Twitch Rival anymore because it's always terrible.
apparently it took like half an hour to get whitelisted.
Don't talk about it. Just go.
Let's just go. We're studying computer. We are studying ciphers, and part of like the cipher that we're doing right now is basic computing, which has to do with computers. So pretty much, yeah. Right. I will stop fangirling about binary to ASCII. Well, binary to readable letters, I guess. To recap, here's how we can decode from binary to plain text. Convert each byte of binary into base 10. Convert the base 10 numbers into plain text by checking them against the ASCII table. Or, as Pam said, you check like the first 3 digits, whether it's a capital or not, and then you count you convert the last part into base 10, and then you pretty much just count whichever letter it is, which is so cool still. To be fair, Blue, I missed a large portion of yesterday's stream. It's, I can't imagine, because he started kind of early-ish in the evening, and he was still going on when I started work this morning. The man's insane when it comes to his streaming schedule. But yeah. Now it's time to try it yourself. Convert this binary into legible characters. Okay, so this means it's a small letter. Yes, that's also not quite the correct phrasing, I think, but whatever. Small letter. And then it's 2, which is a B. That's an A. That's a C. Oh no, wait, we have another one here. Oh, I'm terrible with this though. 1, 2, 4, 16. Yes. So that's 19. So that's S. That is 9. So that's A, and then that is 3. So that's C. I'm not typing. It's great. Basic. All I know is coming into cursed doings and elder. Yes, that's one other reason why I'm hesitant to. Oh my god. So, just, for chat, you sometimes watch Steve something, right?
Yes.
Yes. Apparently in Elden Rings, you can tweak your character very, very, very much.
That's standard for some from games?
Well, as in, you can tweak it so much that you can, like, set the cheekbones and...
Yes. I saw some very, very good characters because of that.
Do you also happen to have heard about Steve's recent haircut?
Yes.
So, apparently, the basic character of Elden Rings made 5 of think of Steve.
No.
Yes.
No.
So he went on to recreate Steve in Elden Rings. With like reference pictures and everything.
I'm gonna need to watch that.
Yeah. So that happened. My pings as soon as I came into chat was stay help us. Leave what you can because of that. What is with this? It's from Sonic Mania, is it? Why are we at hyper potions? I don't want to be at hyper potions. I did this. What? Ugh, it's gonna be another one. Hyper potions is okay with you streaming their music, but the first time you upload your VOD to YouTube, you will get a DMCA warning, and then you have to fight the DMCA warning and you have to send an email, and I haven't yet taken the time to do that. So this is another thought I won't be able to immediately upload. Great. I don't understand why we went to that list though, because I really want... I want Lena. Lena has nice music. Thanks for the heads up though, Tay. Yeah, so this it's like not quite DMCA, but sort of DMCA, and it's just effort. But as soon as you've done that once, it should be good for like the rest of the votes that you upload. So I just really have to do that once. Anyway, what else? Sugar said 011 is small and 010 is capital. Yes, that is very correct. Basic. Well done, you managed to work it out. The next stage should be now unlocked. We're almost at the end of. Okay. Nicely done. Incidentally, it's not only letters that have ASCII codes. All characters have them, including spaces and punctuation. Here are some examples. Okay. Now we're going to give you a much larger block of binaries, so large that it's not feasible to turn into plain text by hand. Kinda want to show them other ways. Kinda. Fortunately, there are online utilities designed for this exact purpose. If you haven't already, you should Google binary to ASCII converter. Here's a binary.
If you wanna do it, but I don't wanna.
I want to do part of it.
You can always do part of it.
Let's do part of it. So 101. That's completely not what it says over here. 010. What are you doing?
010.
Oh.
This one is not yeah, 101. Toch? 010.
No, I said it the wrong way around. It was 010.
This is not the correct one.
That was US ASCII.
Yeah.
It says.
But
Cool. So it's a capital letter, and it is. Why can't I keep track of that? It's 16, and a 16 is a P. It's a capital though. Oh, also I still need to add third-party emotes to this channel. Well, I'm not necessarily in a hurry for that. It was mostly because you want to do those, so you know, you're the one who doesn't have third-party emotes. As long as you don't add them. It's 8, right? Is it? Am I being dumb again?
what?
1, 2. I am dumb. Thank you. With 8. Yeah. I was just testing you. Yep, definitely. Yep. Okay, so then that's 5. And then that is. I'm on mobile, so I can't see them anyway, unless I'm chatting through Dank chat. Which is a very odd word to see like that, but. I'm gonna add them tomorrow. Okay. Okay. While we're on the topic of your mobile phone, I'm almost scared to ask. Is there news? I don't think the boats well. Nope. Oh. Sorry, still. I'll just move on as if I haven't asked, I think. So, this one is. What are you? Is that the correct one?
No.
It was the same,
no,
right?
It's the same one, but I was checking what the difference was.
Okay. Anyway, I keep forgetting what like these digits mean. It's annoying. So this was 8, right? So then that's 16. So that's 24. That is 25, which is a Y. Awesome.
Are you bored yet?
I'm not quite focused, but I'm not bored.
That's a comma, I think. It's not A small or a big letter?
Considering that this is the word hey, I'm going with an exclamation point. Exclamation mark.
Okay.
But we're gonna check it anyway, so. And then this is what's that?
It's an exclamation point. This one is
It has all zeros.
space.
This is not 20.
No, that's 32.
Me confused. But it would have to be a space. Because that's what you
Yes,
put after an
or
exclamation mark.
a comma.
Well, you don't put a comma after an exclamation mark.
No, I really think it's a space.
Whatever. Maybe. I don't know. Whatever. Anyway, so then it's a 011, and that was a small letter, which also doesn't make a whole lot of sense. Because we just had an exclamation mark, so you'd say it's a capital letter.
Let's just put it through.
It was a comma. Hey, how is it going? I hope you're enjoying these tutorials so far. We put a lot of work into them, so it would mean a lot to us if you like them. Anyway, the password is alternative. Oh, fine. Okay, I'll just put alternative there then. Sure. I was about to enter the whole thing. Oh, wait. If that's an exclamation mark, then the other one is a space. Yep, so the exclamation mark is secretly a comma. Yes, the exclamation mark is secretly a comma. Which, I mean, I guess also works, but yeah. Didn't you say that at first, by the way? It's a comma.
Yes.
But then still, how can space be 20 and this one? That still doesn't make sense.
That's just really just wrong. Because it needs to be 32.
Yeah.
1, 2, 4, 8, 16, 32.
Yeah. Whatever.
Yeah, that's a comma. Okay, yeah, go ahead.
Was that a comma?
No, I was thinking of this one. That's a comma.
Yeah, yeah. Okay.
Yeah.
Let's just continue. Yeah, we were already on the end, so whatever. Alright, now let's have a look at some other bases. Base 8 is also known as octal, only uses the digits from 0 to 7. So let's convert 109 from base 10 to base 8. This is a lot of counting.
Yes. And I get why they are doing this. I just want to skip.
We are not skipping. You wanted to do the image thing, and we needed this. So
yeah.
also, this is the last stage. We can make this work. We can.
Yeah.
As you can see, each place value moving to the right of left is worth 8 times more than the previous one because we're in base 8. If you already have a firm understanding of the relationship between binary and decimal, then octal should come naturally. However, we're going to throw another wrench into the works. Fine. All the alternative bases we've looked at so far have used 10 digits or less. What if we want to use a base of more than 10 digits? The most common example of a base greater than 10 is base 16 or hexadecimal, hex for short. Base 16 uses these 16 digits, so it goes from 0 all the way up until F. So once we round out of numbers to use for digits, we start using letters instead. So I have the digit A in the hexadecimal number. Having the digit A in the hexadecimal number means it's equal to 10. The digit B is equal to 11, and so on. Let's look at the number 109 again as an example. So now it's because it's 6. Oh no, this is very. I don't know what else to explain about this.
I can. It's made because 4 binary digits can easily transfer into hexadecimal. That's the really good thing here. But explaining hex is gonna be a difficult one.
Yep. Oh, right. I suddenly remember. I was talking before stream about hexadecimal because I'd seen a code that I thought was hexadecimal because it had a lot of Fs. It wasn't S, it was sixes. Right. It was a lot of sixes. And when there's a lot of sixes in the code, then, because in hexadecimal, the letters are like right around the 60 mark, or what we would call 60 in like when you read them as plain text. Right. That's what was going on. Note. Remember that D is actually a digit here and has a value of 13. Why? Bad font. They chose a really bad font for this. Right. Alright, now we're gonna try to turn some hexadecimal into legible plaintext characters. The process is the same as for binary. Convert each block of hexadecimal into base 10. Convert the base 10 numbers into plain text by checking them against an ASCII table. Well, you know what else you can do? You can just say, Google, give me hexadecimal to plain text. So easy. Google's great some of the time. No, leave me alone. And this is hex to text, and our word is finished. There we go.
Now we go to the good stuff.
You managed to work it out. Finally, the next page is a conclusion. So, nice job. You've reached the end of this tutorial. So let's stop and review what we've learned. Base, a system of counting. So, wasn't also, when you're looking at the... What do you call them? This was called the base, right? The base of a number. Base and exponent.
Yeah.
Cool. I don't think chat cares, but I did. So that base, that's why it's base 10, because it's yes, okay. It's not just a random word. Anyway, decimal base 10 uses digit 0 through 9. Binary base 2 uses digit 0, 1. Octal base 8 uses 0 through 7. Hexadecimal uses digits 0 to 9 and 8 through F, where A is then 10 and the rest just follows it up. ASCII is a standardized method of converting numbers into plain text characters and vice versa, and converting binary or any of those into ASCII, you do it according to them to first translate into base 10 and then check it against an ASCII table. Ooh, we have a bonus puzzle! This puzzle uses methods taught in the basic ciphers tutorial, so make sure you've completed that tutorial first. So this is A. No, it's not. This is a... Fine, we will put that in the translator as well. That was not the translator I was looking for. Very fun. Very much fun. Whoop.
What's that? Hey. Okay.
You wanna still...
No, I was thinking something else, but no. Yeah.
What were you thinking then?
Oh no, no, this is not happening. I forgot.
Oh my god. So chat, can I introduce you to Bram, who most of the time has like the memory of a goldfish?
No! Most of the time I have a good perfect memory. Only like 1/10 of the time I have a memory of a goldfish.
See, it's so bad that I even forgot that. No, kidding. Kidding. No, it's not that bad. But yeah. Some of the time he has the memory of a goldfish. Or he can just lose track of thought mid-sentence.
Yes. It's a really
Annoying.
Really fun power to have.
Anyway, hey, Danny. Danny is here to lurk. Hi. Well, feel welcome. We are going through ciphers and codes, learning. Although part of what we've had so far was already covered in like school and stuff, for us at least. But let's submit nested. There we go. And then we can go to what we actually wanted to do. Oh, okay, fine. Because we wanted to do image steganography, and I still hate that word. I don't think I'm gonna change. We already read this. I'm not gonna read it again. Let's get started. A typical image consists of a grid. That's distracting. Consists of a grid of small square cells called pixels. Each individual pixel is filled with a particular color, and a multitude of pixels create a larger image. Images are often referred to in terms of resolutions. The width and height of the image in pixels. For instance, the resolution of this image below is 800 by 600. So it's 800 by 600 pixels. I am pretty sure that people in on Twitch kind of understand the resolutions. They've been complaining to me about the resolutions not being available that, they want to see.
Yes, and if you do art online, or if you do art digitally, you know about pixels.
Yup. So, yeah. Keeping in mind the resolution of the image above, how many pixels does it... I don't want to... Something like that, I think. Agreed?
48 with 40?
Yes. At least I think it was 4 zeros. Yes, it is. Well done, you managed to work it out. Thanks. Correct. The number of pixels in an image can be obtained by simply multiplying the image's width and height in pixels. That's like... Never mind. Anyway, image files come in a variety of different formats, including... Oh, yeah. Let's not start that again, shall we? I'm just gonna skip past it. Each of these formats have an...
No, you said it to me. Not skipping.
You were skipping over explanations. These are examples. I'm skipping over examples. Why don't you give it a try?
How salty. Chef, but that's Dutch.
Yeah, let's go with that. Chef. Each of these formats has advantages and disadvantages over the others, including pronunciation. For instance, JPG images have small file sizes but do not support transparency. Each format also contains a header, which contains miscellaneous?
Yes, miscellaneous.
Miscellaneous data about the image. For instance, the image's size or aspect ratio. Or when the image was last edited. This type of data is called metadata and exists in a variety of formats, including EXIF and XMP. These, I think you pronounce it EXIF.
I think too.
The following image has a password hidden in its metadata. Find a way to extract it. I don't know how what are we gonna do?
Inspect. No?
Wait.
All right.
Okay.
I
don't think that is how you check, because they're specifically talking about the metadata of the image, right? And this is more the metadata of the page. Isn't it?
I really Yeah, I know how to do it if it's not an online image.
Okay, sugar. Have a good night. Sleep well. And thanks. Can we maybe open the image in a new tab? Yeah. Because then I feel like you see only the image and maybe then it will show up.
And then do that.
I don't like how it's a red herring, by the way.
I want to save it, but
Sure, go ahead. I don't think chat will be able to see. Yeah.
um,
Yeah, go ahead and just plug it there.
yes, I know. You do that. You can.
There is not a whole lot of metadata there.
No, but this is all the metadata.
So it says it was made on October 13, 2016 at 12:36.
Yes. His name is Herring, so I think you need to give him Herring.
We can. Let's see if that works.
F12 or not?
Sure. There are several online utilities that will allow you to browse through an image's metadata. Okay, let's check this out though. Hello? Yes, thank you. Because okay, fine. There is also a way to look into like the CSS part, right? Because that is the image part. We want specifically the okay. Where are my options here?
Yeah, that's what I was searching for too.
Oh, whoops. Good question. Okay, so it told us to use Google. So image meta data checker? Sure, let's do a checker. Oh, this is an EXIF viewer. We want to select. Let's see what that says. Oh, password Helios. Okay. Fine by me. Well done. Just ask Google. If in doubt, when in doubt, ask Google. Well done. At this point, it is strongly recommended that you download an image editor if you do not already have one. For instance, GIMP. Oops. This is gonna be very fun. I don't think installing GIMP is a smart idea.
Don't think, yeah.
Anyway, adjusting the brightness and contrast values of an image can reveal details not visible to the naked eye. Changing the brightness value of an image simply adds or subtracts a certain amount of intensity from each pixel in the image, as seen in the example below. So, normal image, increased brightness, decreased brightness. I don't think we see much more, do we, in this one specifically?
No, I think it's
Just Just an example of what it looks
Yes.
like. The concept of contrast is a little bit more difficult to articulate than the concept of brightness. Essentially, increasing the contrast makes different colors look even more different, and decreasing the contrast makes the colors of an image look more uniform. Here's an example. I think... can I explain it like that? It's going to be very difficult without having something to show for it. I think back in university they showed like you can display the colors of an image as a graph, and if you increase the contrast you just take like the ends of the graph and you put them like up and down.
Okay. Yeah.
That's at least how we used to do that with like black and white images specifically. Note how dull the low contrast image looks and how sharp the high contrast image looks by comparison. There is a message hidden in the image below. Adjust the image brightness and contrast to find it. This image? Okay, let's save it. Okay. That is not the right key. I am pretty sure we can do this online as well. Adjust image. Does it say brightness or contrast? Both. Let's start with brightness. Change your brightness online. Sounds great. Chat's loving this, by the way, because it's all Dutch.
I think.
Okay, so increasing brightness.
Execute. Execute.
Oh, okay, I see. I was checking whether it worked. Sure. Save it. Okay, we also change brightness, change contrast. Number 2, change contrast. It's there isn't much going on, I must say. Like,
Okay.
could be the other way around. Doesn't really look like it has anything, does it?
No.
I can't.
You did contrast and lighting.
Brightness, yes. We can also do brightness the other way around, I guess. So this is the original. We can do, let's maybe not make it completely dark, but... Oh wait, what's that? Oh no, it's dark. Sorry. Does it do anything?
I really don't see anything. You said, oh, what's that? And I really didn't see anything.
Well, because, I mean, we decreased the brightness, but this looks way more blue now than it does over here, if you ask me. But it might be one of those black and blue and gold and white dress type of things.
I just think that there needs to get to be a word. And I don't see a word.
I don't see it either. We try a different tool.
Yeah.
Google. Let's try that one. Woodchop. You're still on that one.
Yeah, go right. Take a stop.
Oh, this is both.
This is really the original?
Yeah. Gee, fines. Do we have an undo button? Yes, we do. Don't we? Oh no, we don't. But that's also great. Fine, open it again. Oh, we can also... Oh, you can do it by there. Okay, good. I mean, yes, it is the original. Because the original already looks really dark. Hey, Rosie! Okay, let's not do 100 then. Let's make it a little brighter, a little bit more contrast. What's a little bit? Yeah, look at that. No? Wait, no, because if we do it again, then we'll be doing it again on that. We won't be doing it again on that. Okay, fine. Not too much, I guess. I do not have the patience for this. I have patience for a lot of things, but this is not among them.
Yeah? No?
What was the music doing over there? I don't know, the music was just gone. Oh my god! I think it said petrol.
Just type petrol because I...
Or Petrov. It could be Petrov too. P-E-T-R-O. I think it's Petrov.
You are not typing?
What's new? Next. Ooh. Well done. Now we're going to take a look at how colors are represented internally. Colors are most commonly represented as a combination of red, green, and blue. This is a terrible blue to use on this background. Any given color consists of these three components: a certain intensity of red light, a certain intensity of green light, and a certain intensity of blue light. Here's how these colors interact with each other. Because we're talking about light, we go to white. It's cool. I also like how black is only on the bottom. I heard they say black is at the bottom. Ooh, oops. The intensities of the red, green, and blue light within a color are each represented with a single byte of binary. 8 digits. The binary translates to a decimal number from 0 to 255. Therefore, any given color can be expressed. I feel like we have, pretty sure most of the people in chat are artists. They will know RGB. Sorry for boring you, chat. By convention, the first number represents the intensity of the red light, then green, then blue. Yes. Cool. You'll recall from basic computing course that a byte of binary can be represented as 2 characters of hexadecimal, from 00 to FF. By performing this conversion, colors can be represented as 3 bytes of hexadecimal. This is the most common way that colors are represented. By convention, the hexadecimal is often preceded by an...
You are gonna try it, not me.
Octothorpe? Octothorpe. Hashtag. Here's what it looks like on the diagram. To test this concept, what is the code of the color below?
No, it's not gonna be in the metadata, is it?
I don't think so. Because I'm pretty sure this is an image. Yes, it is. Well, we never know. Inspect. We never know, because maybe they use that as a save file name. Maybe. Oops, I'm not very high. No, it says color. They saved it under color. Oh, wait. Oh, no, that's the background. Never mind. Never mind. What is that one again? Isn't it like cooler? Something like that. I think that That one can take it, right? I can. What do you call it again? It's like the little tool that allows you to. You're being slow. Fine. How do you call it again?
Pipette? But then...
Nope.
Artist.
Yes, chat, chat. All the artists. What is that? What is that tool called? It's right here. Color picker. Wait. Would have been too easy.
That would have been too easy.
Would have been too easy. I kind of want to. I don't want to save it. Where is my no button? I don't think I'll be able to do what I want to do anyway. Bye. I mean, on the other hand, if I can give it like... That was not what I wanted to do.
Oh my god.
What?
Yes. May I?
We can't... Oh, good luck. That's not trustworthy.
Nope.
That ain't helping. I don't want to know. Fine.
I think you're gonna need to...
Fine. We'll save it. I don't like it. Why isn't there a tool to do that? There has to be a tool to do that. Also, coolers is still not... I hate it. I hate it here. I hate it here so much. Inspect. I'm still gonna try to do it without the saved image. Because I want... Can you copy the link? Copy link address. Yes, please. Oh. Oh, it was without the hashtag, which they don't call hashtag, but I don't care. I'm not gonna save that. I'm not gonna save that. We can find it again if we need to. That we'll need to. Nice job. Color codes can be used to hide messages. For instance, the stripe...
Ctrl-Shift-T, right?
It was a new window.
Then it's...
I don't think Ctrl-Shift-N works.
That's That's not the right one.
Oh no, wait, that was not what I wanted to do. I wanted history, and then you have recently closed. Why doesn't Chrome have recently closed tabs? Windows. Firefox does.
Yes.
Firefox superior proven.
It always has been.
It was HTML color picker, I think.
Is it image color picker? It's the one you already create. No, no.
That's the one. Nice. Oh, chat can't see this.
Yep.
Right. I'm sorry, chat. Whoops. Wait, can they see it when I do it like that? Yes, they can.
Because that girl is
Uh-oh.
just...
We'll make it work. Wait, no, I can... Because I'm inspecting, so it doesn't matter. I don't need it on a new tab.
Okay.
A new window. Anyway, the question was, color codes can be used to hide messages. For instance, the stripes of the colors of the stripes of color in the following image encode a secret message using color codes. Each byte of red, green, and blue can be interpreted as a byte of ASCII. Therefore, each color represents 3 ASCII characters. Decode a message and obtain the password. No, we are not doing that. Inspect. Gimme link.
Gimme.
Copy link address. Beast. Okay, so on this one, I'm just gonna put it in here. This one. I probably don't have to save the spaces in between, right? Because it's gonna be 12 characters. And then we'll see from there where the spaces, if any, should go. I like this one though. This is a free... Oh, I didn't mean to... Sorry, didn't mean to click submit. It's a very interesting one. I like this. This is probably hexadecimal, isn't it?
Yes.
Because it's 70, 77, it's all around 60 again. So then it's hex to plain text again. We've already been going for 1.5 hours, by the way.
It goes. Quickly.
I think we missed something there. Which would be odd, because this would spell out password, which is 3 letters in between and 2 letters in between.
I 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 characters, right?
Mm-hmm.
I think you need to try... Huh?
Wait. With that would not have any effect, right? I think I have a yellow filter on. But yellow filter only translates from what it's supposed...
eyes, right?
Right? Yeah, right? So it wouldn't be able to see that on the...
No. And then we could have not get the right one
Before,
Well,
that's true. It's not doing anything anymore. Ugh. Okay, let's try a different one then. When we have to upload. Please. I don't really care which one you take. Just give me one. That is not what I meant. Okay, so then what did we look up a moment ago? It was like get color from image. I don't care.
Not this one. Oh, it does.
I don't know.
This one
It
with
doesn't. Fine. This one immediately does hex. It also does heat or whatever.
seventeen 76, 17, 77, 64.
That's the same.
Yes.
And then we have 3A206. 3A206F. Which is the same.
Yeah.
Then we have 7. Oh, wait, this one. Wait, what? 3A206F. And now we have the same.
This.
Why is it not? Thank you. So we're missing the third one then, I guess. No, I don't know the number. So it's 3A2, 3A2F.
You're missing a 7.
After this? Oblique. See, that makes a whole lot more sense. Well done, you managed to work it out. That's my issue often with these type of things. I just make these stupid little mistakes and then I get lost. I don't like it. Awesome, that was just... Okay.
It's right.
Yeah, skipping ahead again. I'm kidding. Awesome, that was just one of many ways that color codes can be used to conceal information. Another way of hiding a message in an image is to make small modifications to the colors of certain pixels. These modifications are so small they cannot be seen by the naked eye. Below are two images. The image on the left is the original, while the image on the right contains a hidden message, although they appear identical. To recover the message, you will need to find some way to digitally identify the difference between the images. This can be achieved by searching for an online image difference utility. Thank you. Or by using difference layer in GIMP. Google. Compare differences between images. Great. I will probably
Need to upload.
Fine. Save. This is the original and this. Whatever. And this is the new one. Why does the original have orange as an extension? And why does the new one not have an extension? It just doesn't make sense. Can I? There we go. It's not very useful, is it? Oh, wait, it is. Password. Ixie? There's something before that. Nitty. Inity.
Affinity?
I think the first is a C. Where was that brightness thing again?
I think you need contrast for this one.
Yeah, that's fine. I don't know. I think probably both again. So it was contrast. Oh, wait, what did that say? Sure. That's the one. Can I do it like that again? I really like that. Does it? Yes, it does. Amazing. What?
I don't think. I think they just put two images on top of each other and inverted one. So you got all black.
Wait. That's not fair. Can I put the brightness up here? Like manually. Sorry, chat. That's not going to be very useful for you. Not working anyway, but.
It ends with anything.
The first is a very round letter. I'm pretty sure it's either like a C or a G or
An E. The second one an X.
G. Give. Divinity. I still don't know what the second letter is though. Divinity, which is not a word. So that would make a whole lot of sense. Or divinity maybe, but then the D doesn't really look like a D. What does this do? Gosh, that's very... Thank you. Please help. Drop an image. That's the original. That's the new one. Highlight color. I don't really know. Highlight color black? Because it's the dark part. Like it's the black part that we have issue with. Gosh, that's amazing. Wait.
I think green.
Green?
But you need to drop it again.
Okay.
But I don't see the difference.
Yeah, me neither. Different website. We'll figure it out. Right, Tay? The music's good, right? Are you sure? The difference will appear here. We still can't see it. I don't get it.
I don't see.
Not what I was looking for. Image diff tool. That sounds promising. I like how you're, by the way, dancing without hearing the music.
I hoped you wouldn't say it.
Okay, so I'm guessing original then? What are you gonna compare? I'm so confused. Sure, let's compare one image to what? Can I drag? Can drag. It's great. Highlight color. I don't care. I just want to see what. Thank you. It was divinity. It didn't look like a D though. It looked rounder than a D. Well done! This concludes the image steganography course. Let's review what we've learned. Pixels, square cells that comprise an image. Da Vinci! What's that from again, Da Vinci? No, right. It's what, it's how, Lily pronounces her dog's name after it's been named after a artist. Da Vinci, not key. It annoys me so much. It annoys me so much. It's from those twins. What do you mean, those twins? I can Google it here as well. Is it safe to Google? It's probably safe to Google, right? Da Vinci twins. I'm not clicking that. I am not clicking that. This does not look promising. Why do Brits say Da Vinci? Yeah, kind of curious. I don't know. Do I want to know this?
It's the same one.
We're not watching that, are we? Let's not watch that. I don't think I want to watch that.
I think your computer says no.
Great. Okay, bye. Thanks, Day. That was not where I knew it from, by the way, but yeah. Resolution, width and the height of an image in pixels, metadata. Is it? I keep pronouncing it data. Anyway.
That's our data. Yeah.
I don't know. I don't think
it doesn't matter.
Exactly. Isn't that one of those British American things again?
Yeah, but GIF and GIF doesn't matter either.
Like we just said, GIF and GIF. Sure. Anyway, miscellaneous data about an image. Brightness, the light intensity of an image, contrast the range of colors in an image, color code, 3 bytes or hexadecimal representing the red, green, and blue intensities of the color. It's a magnetic thing. There you go. Yes, that happens. That's why they put a light on the side. I just randomly got reminded of that because of something you said. Can't remember what it was though. Divinity, I think. The techniques we've covered are just a fraction of the most basic techniques for image steganography. There are many more ways of hiding messages in images, so be vigilant. You've also earned a badge for your profile by completing this course. Should we throw this into like a contrast and brightness thing? Because, I mean, it's the end of the course, but...
Could be.
No, ain't doing that.
It's more for... I don't think any of us.
Exactly.
Oh, This is the metadata from the site itself.
Yeah.
Oh, and Boolean. That's a fun one too.
That's probably a fun one. Question is, I don't think we want to do that anymore because I need to get up at like 7.
Okay.
Yeah. So I would want to.
Yes.
I think the smart thing to do is to not start another one.
Just random. Are we smart?
Listen, I've got a reputation to keep up here. So yeah. Well, chat. With that, I think we've reached the end of the stream. I hope you enjoyed it. I hope you enjoyed it too, by the way.
Yeah, I did.
Cool. So, maybe some other time we can play like Keep Talking Nobody Explodes or one of the other games.
Yes.
Sure. Yeah. Let me think. Next stream will be happening tomorrow around about 2 p.m. We're finally gonna start Mew Complex. Took a while, but we're gonna do that. As for next week, I don't really have a schedule yet. But I was hoping to give a couple more streams because I'm off of work. But I don't really have my planning finalized yet. So keep an eye on both the schedule on Twitch as well as in the Discord. Although apparently, like, I haven't really gotten used to being able to use the schedule on Twitch. So the Discord one is more reliable. Also, just as today, where it got put back a little bit, I'll put it in Discord. So Discord's more reliable. Anyway, thank you for being here, and I will see you tomorrow. And then let's see who we're gonna rate, right? I don't have the dashboard open. Great. Let's see who is live. Sure. I want the stream manager though. Give me the stream manager and then raid. Me. You have any ideas who to raid? Are they all live? You're following so many people.
Too much. That's not a good one.
Here's a whole list of people who are streaming and
This one is really, really funny.
which one?
Feathern. She's in Minecrafter, and she also does. Oh, but now she's playing with Bluekwyrm. Minecraft. She's from Minecraft.
I don't know what that is.
Okay, I'll introduce you.
Okay, so we're heading over there. Let's see. Phedran. Feathern. There we go. Okay, so chat, please go and say hi. And see you tomorrow, I think. Okay. Bye-bye. Bye, Tay.
Bye.